All right, Chem 11, this is our second video on the mole. It picks up where the last one left off. All right, so last one left off with us talking about the mole relating back to balanced chemical equations, and now those coefficients that balance an equation, we now know that those numbers refer to the number of moles. And because we can make a connection to mass, we now know that, instead of looking at chemical equations in terms of molecules, we can look at it in terms of tangible amounts that we can handle inside of the lab. We're going to go even further with that with this video today. We're going to learn about converting moles into number of particles. So if I gave you a certain number of moles, like say 5.5 moles, you could tell me exactly how many atoms or molecules there are in that 5.5 moles. Pretty easy math, even though the number for a mole can be quite intimidating and big. It's not a big deal. So we know that 1 mole is equal to, and I'll use the scientific notation because we saw in the last video that the number was actually very, very big. So this is particles. Now the particles could be atoms, or they could be molecules. Now when I work with a certain substance, if it was say calcium, well, calcium's an atom, so I put atoms where particles is. If I was working with glucose, glucose is C6H12O6, that's a molecule. It's not an atom, it's a molecule. Molecules would go there, all right? So I was working with something like calcium, I'm using atoms. If I'm using something that has several elements in it, I would use molecules instead of the word particles. But particles is a general term, so we'll leave it for now, all right? So what we want to do today is we want to be able to transfer between particles and moles. It's very, very important, right? In order to do that, we have to know that 1 mole is equal to that. Well, we already established that in the last video, so we should be good with that. 1 mole is 602 hexillion, or 6.02 times 10 to the 23rd of something. In chemistry, it's going to be some sort of particle. But we could have it be anything. We've talked about that. Jelly beans and pencils and everything else. So the conversion factor here is this knowledge, all right? So the following is going to help you, but first we're going to talk about eggs, all right? So I'm going to move our iPad for a second here, and let's talk about eggs. Who doesn't want to talk about eggs? My eggs, my eggs. Anyway, eggs. So there's 2 ways of looking at eggs, right? You can look at individual eggs, or we could look at dozens, right? So we can buy individual eggs, or you can buy eggs by the dozen, all right? So, for example, if I said, hey, I bought 24 eggs today, you would say, oh, you mean 2 dozen? And I would say, well, how did you know that? I bought 24 eggs, and you automatically said, oh, 2 dozen? You would have to know what's called a conversion factor, and that conversion factor is this. Your brain quickly said, well, there's 12 eggs per dozen, right? And so if I had 24 eggs, you simply divided by this conversion factor and said, well, 24 divided by 12 is 2. 24 eggs is 2 dozen. And I'd be like, oh, that's not too bad. Okay, that works. Or I might come home one day and say, hey, I bought 3 dozen eggs. And the wife unit might say, oh, so there's 36 of them? I'd be like, well, how did you do that? 3 dozen eggs, and she quickly turned them into individual eggs. Again, she knows that there's 12 eggs in a dozen. But this time what she did, because we started at this end, dozens, she multiplied. And she said, well, 3 dozens times 12 eggs in every dozen has given me 36 eggs, right? So this right here is our conversion factor. We need to know that fact to be able to go back and forth, right? So let's do another one. I brought home 60 individual eggs. I have 60 eggs. 60 divided by 12 eggs per dozen would mean I brought home 5 dozen eggs, right? Or maybe I brought home 10 dozen eggs. 10 dozen times 12 eggs per dozen means I have 120 eggs in the fridge, right? So going from individual eggs to dozens, I divide. And from going dozens to individual eggs, I multiply. So if I start here and go here, I do one thing, divide. If I start here and go here, I multiply. And in both cases, I'm multiplying or dividing by this conversion factor. It's very, very important. And we know there's 12 of anything in a dozen, right? So it doesn't have to be eggs. It could be TVs, right? It could be candles. It could be dogs, whatever. But we know there's 12 per dozen. Just like we know there's 602 hexillion in 1 mole. Now, this math does work out. Let's do a couple of examples. We're still talking about eggs. What else would we talk about in chem class but eggs? So let's do a couple of examples. So let's say I have 36 eggs, and I want to know how many dozen is that going to be? Again, we said what we're going to do is, and if you think about what we just had up on the board here, we divided it by our conversion factor. The conversion factor, I will put that in a different color. I'll use red for our conversion factor, right? So our conversion factor was, I had to know there's 12 eggs per dozen. All right, so there's our conversion factor. And look what happens. And you guys that are taking physics or doing any math, you know that a unit divided by a unit reduces to 1 or cancels out. Math, they say, reduces to 1. It cancels out. So look, 36 eggs divided by 12 eggs. Eggs divided by eggs is no eggs. Eggs is gone as a unit. The only one that is left is dozen, and that's what we're looking for. And then numbers, 36 divided by 12, that's going to be 3. So I have 3 dozen eggs. 36 eggs is 3 dozen. Bravo, well done. Simple math, right? Anyway, let's do it the other way. I have 5 dozen eggs, and I want to know how many individual eggs do I have, right? So how many eggs would that be? And your brain does this because it's used to this. Your brain does it like that, right? What our brain's got to get quick at now is this conversion factor, which we'll get to. So again, I'm simply going to write my conversion factor. I need to know that there's 12 eggs per dozen. And in this instance, we're going to multiply. To get the dozens to cancel out, I know that dozens on top and dozens on bottom will cancel out when I multiply. Because technically this is over 1, right? So a top and a bottom of a fraction, when I multiply, they cancel. So dozens on top, dozens on bottom, when I multiply, cancels. The dozens is out of the picture. All I'm left with is eggs, which is what I want. And 5 times 12, I deal with my numbers. That's going to be 60. Now your brain does this automatically. It's very, very quick. So now let's look at this conversion factor, okay? Using the same process, right? We're used to this math. Let's apply that simple math of eggs to this simple concept. 1 mole is 602 hexillion, or 6.02 times 10 to the 24 molecules. So now we've got our individual things aren't eggs, they're particles. Right? This is like our eggs, our individual things. We know it's going to be an atom for one instance or a molecule for another, but we'll say particles. And we know that just like dozen is a word that means a specific amount, mole means a specific amount, right? I'm going to stretch that out a little bit because I know my conversion factor is going to be a little bit bigger. So there's moles. All right. Now, if I'm going to go from a certain number of atoms and find out how many moles of that substance I have, I'm going to go like this. Or I want to be able to go from moles to number of particles. Hey, I gave you 4.5 moles of water. How much does that, how many particles are in there? How many molecules are there? So I want to be able to go from individual atoms or molecules, particles, to moles. All right? Because the moles is what I can actually see and use in a chem lab. It's tangible, right? So I need my conversion factor. In the last example with the eggs, it was 12 eggs per dozen. Here, my conversion factor is 6.02 times 10 to the 23 particles. Make that a little neater. Particles per mole. All right. To turn my individuals into groups, if you remember, we divided. All right? Just like going eggs to dozens. I divided. 36 eggs was 3 dozen. I took 36 and divided by 12. So same idea here. We're dividing. Now, if I had 5 dozen eggs, I multiplied by 12 to get the 60 eggs, individual eggs. So I'm doing the same thing here. This is my large grouping, like a dozen. This is my individual eggs. I multiply. So the thought process is the same. This number is new, so it makes it a little bit tougher. All right? So this is what we're going to be doing now. To do these calculations, we should have a scientific calculator, and then we have to practice at putting this value into our scientific calculators. In chem class, when we have regular session, we're in the room, I actually take 5-10 minutes for you guys to figure out what you have to do on your calculator, because different brands have different sequence of buttons you have to push. So all I did, I got my conversion factor, which I knew from this relationship, I put it there, and then we work on our calculators and figure out how to do that. So let's do a couple of really simple examples, okay? So our first example, what if I had 3.4 times 10 to the 24 atoms of calcium or copper, carbon, oxygen, whatever it happens to be. But if I had this many atoms, that's my individual particles, and I wanted to figure out moles, what would I do? Well, if I go back and review that lecture, and I had that, the arrow thing, I divide. I'll put that in a different number. That's my conversion factor. So my conversion factor I'll put in the blue. I divide by 6.02 times 10 to the 23. I don't write particles because it said atoms, so I use atoms, the particles that were given. All right? Per mole. All right? So I started with individual particles. I want to go to moles. I'm dividing by my conversion factor. My conversion factor was this relationship here. That doesn't change. That's a statement of this fact. 1 mole is 602 hexillion of something. All right? So now, on your calculator, your challenge is to put this in, figure out how to do this, and how to do that, and get the answer I'm about to give you. And my answer, when I do it with my calculator, I take this and divide it by that, is 5.65. 5.65 moles. All right? Now, here's a hint. What you may have to do You're going to have to figure out how to do the powers button, how to use exponents. But what I find helps is with some calculators, when you type it in, you type 3.4 times 10 to the 24th, and then people will go divide it by, and everything's great to this point. And then they type in 6.02 times 10 to the 23rd, and they don't get this. They get some ridiculously high number like 10 to the 40 something, right? They end up with some number that is whatever, blah, 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 times 10 to the 44 or 45, whatever it happens to be. If you're getting this, here's what your calculator is doing. It's doing this part fine. It takes this really, really big number. We said this was 602 hexillion. This is even more. Look, this is 24. This is 23. So this is even bigger. This number is even bigger than a mole, which is already a really big number. It's taking this really, really big number and dividing it by 6. Well, that's still going to give me a really, really big number. And then it's multiplying it by the hexillion thing again. So you're getting a crazy big number. So what you will have to do with your calculator, most brands, you will have to use your brackets when you're entering this on your calculator. So you set up this number and then divide by and then use the bracket. And then put this in and the bracket. And when you do that, that's when you'll get your proper answer of 5.65. I rounded it off. It was like 5.6478, something like that. So that's our proper answer. And of course, show the units because I don't want to throw marks away. All right? So use these brackets on your calculator. You're probably going to have to do that. If you get, like I said, 10 to the 40 something, your calculator is telling you, hey, use brackets around this thing and you'll be fine. All right? So try this with your calculator right now. Use these numbers, 10 to the 24, 10 to the 23, put those numbers in, keep working and figure out what you got to do to get 5.65. I'll set up our next question. I guarantee you're probably going to have to use the brackets like we said. All right. Now, I can also go the other way. I can start with moles. Like we said, we can start with dozens and work our way to individual eggs. We can start with moles and work our way to atoms. So, our next one, what if I had 7 moles? And I wanted to know, hey, how many atoms would that be? All right. Now, I know 1 mole is this amount. So 7 moles would be, well, 7 of these. So I'm multiplying here, right? So I'm multiplying it by, again, our conversion factor. I'll write it in blue because it never changes. 6.02 times 10 to the 23. My particles, I don't write particles, I write atoms because it's used here. Again, in our calculation, we're always going to be using atoms or molecules instead of the word particles. So there's my conversion factor. They're the same. Even though I'm starting with atoms going to moles, starting with moles going to atoms, this doesn't change. It's what you do with it that changes. So there's my conversion factor, which relates back to this statement, which we already know. And it equals, and again, you may or may not have to use the brackets. I'm just using my calculator here. So the answer to this one is going to be 4.214 times 10 to the 24 atoms. So this is the answer you've got to get on your calculator to know you're doing it right. All right. Does that make sense? I will do a couple more in just a second. All right. So atoms to moles, we divide by our conversion factor. Going the opposite way, moles into particles or atoms, I multiply by our conversion factor. It seems more difficult now because the number is larger, but again, when we were talking about the eggs, you were probably doing that in your head. All right? So again, very important, pause this video right now. Make sure you can get these answers on your calculator. These are the correct answers. Figure out what you got to do. I guarantee you probably got to use brackets in there somewhere. All right? So do that. I'm going to keep going because you can always pause this video. We'll do 2 more. All right. Example number 3. What if I had 0.75 moles? So I don't have a full mole, right? And this time I want to know how many molecules. How many molecules of something? So I'm going from moles to particles, right? Molecules are particles, right? We said we'd never write that. We're going to write this. That are atoms. So I write my conversion factor. My conversion factor, I'm going to write it in orange, just like that, for this board anyway. My conversion factor is 6.02 times 10 to the 23. In this case, I'm not writing particles, I'm writing molecules per mole. All right? Now I can remember my thing from before, and it's going to be multiply, or I can kind of cheat and use previous learning from math class. I have moles on top and moles on bottom. I know to get rid of that, I multiply. All right? So there's my conversion factor. It's this statement basically brought together here. And we'll see how much that is going to be. So when I put that into my calculator, now, a little bit of common sense. Right? If you're watching Trailer Park Boys, Ricky never uses common sense, and Bubbles and Julian always have to say to him, think, Ricky, think. Right? So at this moment, let's think, Ricky. This is less than 1 mole. Right? This is 0.75, so it's 75% of a mole. It's not a full mole. It's not 100% of a mole. So my answer, if I have less than 1 mole, and this is 1 mole, my answer should be smaller than this. It should be smaller than this number. This is 1 mole. This is less than that. So let's see. I'm going to have to put this answer down here because I know I'm not going to have space. So I'll write molecules over again. Very messy, but we'll have to live with it. So 0.75 times that value equals, I end up with 4.515 times 10 to the 23 molecules. So there's my answer. I can actually draw that in there a little bit nicer. Because moles on top, moles on bottom cancel or reduce to 1 when I multiply. So again, try this with your calculator. This is what you have to get. So figure out what sequence of buttons you have to push to get this. All right? I'll do one last one, and then we'll call it a day here for this section of the video. So you can pause that if you needed to pause it and look at it again. Just pause it, and we'll move on. This time we'll go with 9.2 times 10 to the 22 molecules, and we want to know how many moles that's going to be. All right, it's time for another one of Mr. Mack's common mistakes. All right, I'll tell you about the common mistakes that are made over 20 years of teaching, and you try not to make them. I'll ask, we'll do our Think Ricky Think thing here. I have this many molecules. Should my answer be 1 mole, more than a mole, or less than a mole? And people will look at this and go, oh, 9.2, that's more. Right? This is 6, that's 9, that's more. Not so. What we have to look at is this and this. Because this is 10 to the 22, and this is 10 to the 23rd, this is a higher power. This number is greater than this number. this is actually smaller because this exponent is smaller than that. So I have less than a mole. This exponent is more important than this front number in terms of how big the number is. So I have less than a mole here. So my answer should be less than 1. All right, so it should be 0 point something. I'm going to write in my conversion factor in orange just like it is there. And this is 6.02 times 10 to the 23. Molecules are our particles this time per mole. Now, I start with molecules. I want to get to moles. I know something's got to cancel out. I got to get rid of these molecules. How am I going to do that? Well, they're both on top. When they're both on top, I divide. Right? So I divide by, again, I'm dividing by this conversion factor, which we know. And so now let's do that. So what I end up with is 0.15. Yeah, we'll leave it there. It's 1528, but I'll leave it there. 0.15 moles. Now that answer is less than 1, but we said because of the powers that we're comparing, 22 to 23, this is less than 1 mole, right? So my answer makes sense. Think, Ricky, think, right? So again, on your calculator, try this, divide it by that. This is what you need to get. All right? You may need to enter brackets around this number on your calculator, right? So try that. Pause the video right now, give that a try, see if you can get that number, that answer. I'm going to move on. I'm bringing this back in. All right, so here's our number of particles. Here's our number of moles right here. This is just what we were doing, thinking it out with our own brains. But here is a little kind of one of those circle diagrams, right? So there it is here. To go from particles to moles, I divide by 6.02 times 10 to the 23 particles per mole. To go from moles back to particles, I multiply by that. All right? So that's it for today. We'll move on to that next topic in the next YouTube lecture. I'm going to write out that thing for you so you can get it down in your notes. I would write this on the back of the periodic table that I'm using for all of my chemistry stuff. So we had number of particles, and then we had moles, right? I'm going to do this with the conversion factor in the middle. The conversion factor was 6.02 times 10 to the 23rd. I wrote that too big. I'm going to have to write it a little bit smaller. 6.02 times 10 to the 23rd particles per mole. All right. That's our conversion factor. If we're going from moles to particles, I'm going to multiply. If I'm going from particles to moles, I'm going to divide. All right, you can write that down on. So I take this, divide it by that to get these, and I'm starting with moles. I take my number for my moles, multiply it by this to get to that. All right, hopefully that was clear. And again, use this video. Tyler DeWitt is an excellent example. He's got some great mole videos, of course. Use more than one source. I actually, on my YouTube page, in my links section, I have some great YouTubers that do amazing stuff in science. Crash courses there, Khan Academy. Tyler DeWitt would be my chem guy. He's an amazing teacher. Look at his videos as well. He does a lot of great things. So hopefully this made sense for you today. The next video, we'll be looking at mass, because in the lab, we don't have a scale that measures moles. We don't have a scale that measures particles. All our scales work on G's, grams. So this will be our next thing, going to mass. All right. Take care. We'll see you soon. If you have comments or questions or concerns, throw them in the comment section of the YouTube video down below, or reach out to me through Edsby, and I'll get back to you as soon as I can. Thanks for watching. Bye-bye.